Far below the reach of sunlight, where the ocean stops feeling like water and starts feeling like outer space, something waits with its mouth already open, not charging, not chasing, just waiting. In that black, pressurized wilderness, a fish hangs nearly motionless, a thread of living light swaying from its chin, like a last star in the universe. Then, the darkness moves. A smaller animal drifts closer, drawn by a glow it cannot understand. There is no roar, no warning, no splash. Only a snap so fast, it is almost theoretical, and then the victim is gone, swallowed by a face that looks less like evolution and more like a nightmare remembered by the sea. This is the dragonfish, Stomiidae, a family of deep-sea predators so specialized, so visually extreme, that even scientists still speak about them with a mixture of fascination, caution, and disbelief. To understand the dragonfish, you have to first understand its world. Most of the ocean is not blue. Most of it is black, cold, and under pressure so immense it would destroy an unprotected human body without effort. Below about 200 meters, the deep ocean begins, dark, food-poor, and crushed beneath tens to hundreds of times the pressure at sea level. In the mesopelagic twilight zone, between roughly 200 and 1,000 meters, only a faint ghost of sunlight survives. Deeper still, in the bathypelagic, sunlight disappears completely. The water hovers near 4 degrees Celsius. The only lights left are biological, tiny flashes, pulses, glows, traps, signals, lies. In that world, visibility is power, and invisibility is survival. Every shape is a risk. Every glimmer can be a promise, a warning, or a death sentence. And the dragonfish belongs perfectly to that realm. Recent taxonomic work places more than 350 species in the family Stomiidae, making dragonfishes one of the most diverse predatory groups in the open ocean deep sea. They occur throughout the world's oceans, from the mesopelagic into deeper waters, and some species range well into the bathypelagic zone. Researchers describe them as important trophic mediators in deep pelagic ecosystems, linking shallower waters to the deep through their movements and feeding. But for all that diversity, they remain among the least personally familiar animals on Earth. Many species are known mostly from net captures, preserved specimens, and fleeting video encounters. Adults are especially hard to sample, and researchers studying their reproduction have said outright that our knowledge is limited, in part because the larger, mature fish are simply too good at avoiding capture. That mystery deepens when you follow the dragonfish backward in time. The modern fish itself is not a living fossil in the lazy pop science sense. It has evolved, diversified, and radiated into many forms. But the broader lineage that gave rise to dragonfishes appears to trace back to the late Cretaceous. Molecular work on stomiiform fishes suggests crown stomiiform diversification began around 91 million years ago. Deep-sea colonization studies indicate that major fish occupation of the deep ocean expanded after the most recent great oceanic anoxic event around 94 million years ago, as deep ocean basins became more oxygenated and global circulation patterns shifted. In other words, the ancestors of dragonfish were rising in a world being remade. When the planet's oceans were reorganizing, the Atlantic was still becoming the Atlantic, and the deep sea was opening as a permanent frontier. That timing may help explain one of the great emotional hooks of the dragonfish, why this lineage endured while so many others vanished. We cannot prove a single reason, but the evidence points toward a combination of advantages that feel almost ruthless in their elegance. Dragonfishes are pelagic, globally distributed, and adapted to a habitat with few fixed landmarks and fewer competitors than the crowded, sunlit world above. Their realm is stable in one sense and punishing in another. No storms, no seasons like the surface, but constant darkness, constant scarcity, constant pressure. Species that survive there do so by wasting almost nothing. The dragonfish strategy seems to have been simple and brutal. Be invisible, be efficient, and strike only when success is likely. That is an inference from what we know about deep-sea colonization, the family's global spread, and its ambush-based ecology, but it is an inference that fits the evidence unnervingly well. Seen up close, a dragonfish does not merely look strange. It looks engineered to disturb you. Many species have elongated, dark bodies, like strips of muscle cut from the night itself. Their jaws are oversized, their teeth sharp and curved, and in some forms the head seems almost too small for the mouth it carries. A scaly dragonfish, Stomius boa, can live between about 200 and 1,500 meters and reach roughly 32 centimeters in length, but size is deceptive. In the deep sea, a fish does not need to be large to be terrifying. It only needs the right geometry. A mouth big enough to create opportunity, teeth shaped to deny escape, and a body dark enough to erase its own outline. Many species also carry a chin barbel, a dangling, luminous filament that turns the fish's face into a trap disguised as hope. Mbari researchers describe dragonfishes as cunning predators, and that word matters. They are not simply violent, they are strategic. Although capable swimmers, many prefer to lie in wait and ambush fishes and crustaceans, rather than spend precious energy in prolonged pursuit. Some species hover in the water column like suspended punctuation marks, all menace and patience. Others remain close to the seafloor as adults, while smaller or different species occupy open mid-water. The barbel is more than decoration. Recent work suggests that across the family, the bioluminescent chin barbel likely plays roles in prey attraction and probably in communication between dragonfish themselves. In some groups, species differ so strongly in barbel form that researchers suspect these structures are part of how species recognize one another in a place where faces disappear and distance is mostly darkness. Then there is the skin. Some dragonfishes and close stomiid relatives are not merely black, they are ultra-black. So black that they absorb at least 99.5% of the light that hits them. Smithsonian and Duke researchers showed that this effect comes from the structure and arrangement of melanosomes in the skin, which trap incoming light so efficiently that the fish can appear almost featureless, like a cutout in reality. Karen Osborne, who helped study these fishes, said photographing them on board ship was maddening because they seemed to swallow the light no matter how the camera was set. In the deep sea, where bioluminescent flashes can expose a body the way a flashlight exposes a burglar, this is more than dramatic coloration. It is optical erasure. The dragonfish does not simply hide in darkness. In some species, it becomes darker than darkness looks. As if that were not enough, some dragonfishes took stealth even further by making their weapons almost invisible. In 2019, researchers studying Aristostomia's scintillans found that its transparent teeth are nanostructured in ways that reduce light scattering. That matters because many dragonfishes spend time with their jaws open, waiting. Visible fangs would betray the trap. Transparent fangs do not. The study concluded that the teeth's nanoscale structure helps the wide-open, saber-lined mouth disappear against both the black body of the fish and the darkness behind it. Imagine the evolutionary cruelty of that design. A predator whose ambush works best when its own bite cannot be seen until it is already closing. In the abyss, concealment is not just about the body. It extends right down to the edges of the knife, and still the dragonfish was not done modifying itself. Several genera possess one of the strangest anatomical innovations known in fishes, a flexible, functional head joint between the skull and the first vertebra. PLOS ONE research showed that this unusual connection allows some dragonfishes to elevate the head and achieve mouth gapes up to 120 degrees. That is a monstrous advantage in a habitat where meals are unpredictable and often too valuable to lose. If prey is scarce, then a predator benefits from being able to engulf something large whenever the opportunity finally arrives. The dragonfish turns its own skeleton into an instrument of desperation and success. Part hinge, part trapdoor, part-swallowing machine. It is the kind of adaptation that makes sense only in a world of long hunger and sudden luck. Bioluminescence is the dragonfish's most haunting tool because it transforms darkness from an obstacle into a language. Dragonfishes carry photophores, light-producing organs, along the body, and in some species a glowing lure hangs from the chin. These lights can attract prey, but they can also conceal the hunter. Counter-illumination allows animals to produce light along their undersides, to match the dim light filtering down from above, reducing their silhouette when seen from below. In the open mid-water, where there are almost no rocks, plants, or caves to hide behind, that trick can mean the difference between invisibility and exposure. A dragonfish can therefore glow to vanish, which sounds impossible until you remember the deep sea rewrites the logic of everything. Down there, light is not only for being seen, it is also for not being seen at all. Some dragonfish species go even further into what feels like science fiction. Most deep-sea bioluminescence is blue-green, because those wavelengths travel best underwater, and most deep-sea animals see that range. But a few loose-jawed dragonfishes evolved the ability to produce far-red light, a private wavelength in a world where most other deep-sea animals are effectively blind to red. Research on Malacosteus and related genera shows that they both emit far-red light and possess visual systems shifted to detect it. Smithsonian explains the consequence simply. By making and seeing red light in the deep sea, these dragonfish can illuminate red prey or communicate while many surrounding animals remain unaware. It is the abyssal equivalent of carrying a flashlight only your own side can see. In a habitat built on concealment, that is not just adaptation, it is espionage. What does a dragonfish actually hunt? The answer is more revealing than the horror movie face suggests. Detailed trophic work indicates many dragonfishes are primarily fish eaters, often centering on lanternfishes, one of the most abundant and ecologically important groups in the twilight zone. Other prey include bristlemouths, oceanic basslets, big scales, cephalopods, and even other dragonfishes. One 2023 study found something particularly interesting. The variety of dragonfish barbel forms is far greater than the variety in their diets would suggest. In other words, their bizarre diversity may not be explained by food alone. That opens one of the most tantalizing possibilities in dragonfish biology, that some of their elaborate light organs and barbel shapes are not just bait, but identity, signals, passwords, recognition codes in a black ocean where getting the wrong flashback could mean courtship, competition, or death. Their daily life may be even more dramatic than their anatomy. Researchers report that most stomiids are vertical migrators, spending daytime deeper in the mesopelagic or bathypelagic, and then moving upward at night, sometimes into the upper 200 meters, to feed on the great nightly rise of lanternfishes. This matters ecologically because dragonfish help move carbon and energy from the productive surface-linked food web back into deeper waters. But it also matters cinematically. Imagine that commute. Each night, a predator built for darkness rises through dim layers of water toward the edge of the human world, feeding under cover of night before sinking back into blackness by day. It is not a migration across land. It is a migration through pressure, temperature, and light itself, a daily ascent and descent through invisible borders that would destroy many other animals. And yet hunting is only half the story. Reproduction may be even harder. In the deep ocean, individuals can be separated by enormous distances. And finding a mate in near total darkness is an evolutionary problem bordering on the absurd. A 2024 study on 2 dragonfish species found that males have larger eyes, improving detection distance and helping close what researchers call a visual signaling gap. The logic is heartbreaking in its own way. Females can detect males more readily, so males appear to have evolved larger lenses to gather more photons and improve their chances of finding the opposite sex in the black. Think about what that means emotionally. This is an animal often portrayed as a monster, yet part of its body has been shaped by one of the oldest vulnerabilities in nature, the fear of being alone in the dark and never finding another of your kind. This is where the documentary lens becomes essential, because what we know about dragonfish comes not only from dead specimens, but from moments of encounter. NOAA's Okeanos Explorer captured Melanostomia's melanops on video during a 2019 deep-sea expedition and noted the animal's glowing body rose, luminous chin lure, and tendency for large adults to spend time close to the seafloor. Mbari, after more than 3 decades of deep-sea observation and over 28,000 hours of footage, reported seeing one particular species, the high-fin dragonfish, only 4 times. When that rare bronze animal appeared, Bruce Robertson said it was gorgeous under white light. That is one of the great truths of deep ocean biology. The animals that look most demonic in isolation often become almost unbearably beautiful when seen alive, moving in their own black kingdom. Even the people who know them best still sound astonished. And because sightings are so rare, myth rushes in to fill the gaps. The name dragonfish is no accident. Humans have always used dragon language for creatures that combine armor, teeth, darkness, and fire, or in this case, light. The dragonfish earns that comparison honestly. It is a predator that glows from within, vanishes in plain sight, and attacks with invisible fangs. But unlike a myth, it is constrained by physics and scarcity. It must make a living in a place with almost no shelter and unpredictable food. That is what makes it more unsettling than a fantasy monster. It is real. It is not supernatural. Its features were purchased through ordinary evolution, through millions of years of trial in conditions so extreme that success begins to look like sorcery from the outside. The unanswered questions are where the tension sharpens. Scientists still do not fully know how many dragonfish behaviors play out in the wild, species by species, because most encounters are brief and many adults evade nets. How much of the barbel is prey lure and how much is social signal? How species-specific are those light patterns? When 2 dragonfish meet in darkness, are they seeing a stranger, a rival, a mate, or simply a moving source of food? Why did some lineages evolve extraordinary red bioluminescence, while others perfected ultra-black camouflage instead? And how did a family living in one of Earth's least structured habitats become so species-rich in the first place? Recent work suggests dietary specialization alone cannot explain that explosion of forms, which means dragonfish diversity may be telling us something profound about communication, mate choice, or fine-scale ecological partitioning in an environment we still barely perceive. That is also why the dragonfish matters beyond shock value. Its skin has already inspired interest in bio-inspired ultra-black materials. Its teeth reveal how nature can build transparent, load-bearing structures that stay deadly while remaining optically discreet. Its head joint challenges assumptions about vertebrate mechanics. Its red light vision and bioluminescence stretch what we thought deep-sea visual systems could do. And its place in vertical migration means it is part of the machinery by which the twilight zone moves energy and carbon through the ocean. Study the dragonfish long enough, and it stops being a freak of nature. It becomes a library of solutions, optical, structural, ecological, written in flesh by the oldest engineer on Earth, selection under pressure. But the modern world has begun pressing back into the deep. Reproductive studies in the Gulf of Mexico note that dragonfish ecology is still poorly understood, even as deep pelagic systems face contamination and industrial risk. Researchers reported elevated PAH contamination in deep pelagic fish tissues and eggs after the Deepwater Horizon era, underscoring an uncomfortable fact. The deep sea is remote, but it is not protected by remoteness anymore. The dragonfish evolved to beat darkness, pressure, hunger, and the gaze of predators. It did not evolve for oil, plastic, noise, or a warming ocean whose consequences are still spreading downward. We tend to imagine the abyss as timeless. It is not. It is connected to us by every current, every spill, every appetite, and every decision made far above the waterline.
Look at the lure.
So when we picture the dragonfish now, we should picture more than a monster face and a glowing lure. We should picture a lineage born in ancient oceans, refined across millions of years into one of the most sophisticated ambush designs in the sea. We should picture a hunter that uses darkness like architecture, light like deception, and anatomy like a set of hidden tools. We should picture a world where red can be invisible, black can absorb almost everything, and a mouth can disappear until the instant it closes. And above all, we should picture how little of that world we have truly seen. Because every expedition that lowers a camera into the deep returns with the same message, spoken in different ways. The ocean is still keeping secrets. Maybe that is the final power of the dragonfish. It does not just frighten us because it looks alien. It frightens us because it reminds us that alien worlds are not somewhere else. They are here, on this planet, beneath a few kilometers of water, alive and hunting in the dark while we sleep. Somewhere tonight, a dragonfish will rise through the twilight zone, carrying its own lantern, its own camouflage, its own private signals, and its own ancient hunger. It will drift through black water, older in spirit than memory, in a place where sunlight dies and biology learns to glow. And then it will vanish again, back into the pressure, the silence, and the unfinished mystery of the deep.